students, welcome back to the discussion of the chapter Electrochemistry, and we are going to continue with our discussion on the numericals on Nernst equation. So let us consider a numerical here. Construct a cell containing zinc electrode and hydrogen gas electrode. What will be the EMF of the cell at 25 degrees Celsius if zinc ion concentration is given as 0.24 molar, H plus ion concentration as 1.6 molar, pressure of hydrogen gas as 1.8 atmospheric pressure, and we have also been given E naught Zn as minus 0.763 volts. That is, a reduction potential of zinc is given as minus 0.763 volts. Alright. Now, this question is consisting of two parts. First of all, we are supposed to construct a cell. Alright. And next, we are supposed to find its EMF. So let us get into the solution for the first part of this numerical. Now, you can clearly see here that the zinc half cell has got a lower potential compared to hydrogen gas electrode, because zinc half cell has a potential of minus 0.763 volts, right? But for hydrogen gas electrode in standard state, its potential is 0, right? So it is quite obvious that in this particular cell, hydrogen gas electrode would be cathode and zinc electrode would behave as anode, right? So now let us write the cell representation for a given cell. So you have zinc electrode, which is written at left hand side because it is anode, and hydrogen gas electrode, which is written at right hand side because it is cathode. So that gives us the answer for our first part of the question, that is constructing a cell. Now, we are supposed to find its EMF. And to find its EMF, we will be using the Nernst equation. And for Nernst equation, we need to have the entire cell reaction with us. Okay? So now, simply writing the half reactions here. So reaction taking place at anode. Zinc solid gives us Zn2 plus ions aqueous plus 2 electrons. At cathode, you have 2 H plus ions aqueous plus 2 electrons giving H2 gas. Right? So the next cell reaction here would be Zn solid plus 2H plus ions aqueous giving us Zn2 plus ions aqueous plus H2 gas. So that is the overall cell reaction. So the Nernst equation for this particular reaction would be E cell is equal to E naught cell minus 0.0592 upon N log to the base 10 concentration of products upon concentration of reactants, right? So here the products were Zn2 plus ions concentration multiplied by pH2, that is pressure of hydrogen gas, upon concentration of H plus ions square. So now, let us first of all find here the E naught cell, which is E naught oxidation plus E naught reduction, right? So E naught zinc plus E naught hydrogen. So here we will be writing the oxidation potential of zinc, which is positive value 0.763. And we know E naught hydrogen is 0, right? So basically 0.763 plus 0, which is actually equal to 0.763 volts. That is the value of E naught cell. Also, we know the values of N. N here obviously will be 2 for the reaction. Concentration of zinc ions would be 0.24 molar. Concentration of H plus is 1.6 molar, and the pressure of hydrogen gas is 1.8 atmospheric pressure, right? So simply substituting these values. So E cell now becomes 0.763 minus 0.0592 upon 2 log to the base 10, 0.24 into 1.8 upon 1.6 square, right? So now let us first of all understand the calculation of this log term. That is log of 0.24 plus log of 1.8 minus 2 times log of 1.6, right? So here we basically have bar 1.3802 plus 0.2553. So adding these two values, what do we get? Bar 1.6355. Alright. From this value, we are going to subtract the 2 times log of 1.6, right? So minus 2 times 0.2041. 0.4082, right? So basically bar 1.6355 minus 0.4082, the answer comes out to be bar 1.2273. Now students, this value bar 1 is negative and 0.2733 is the positive value. So precisely, we need to convert this entire value into the negative value. So how do we do it? So we have here bar 1.2273, right? So we split it into two parts. So bar 1 plus 0.2273, right? We add 1, we subtract 1. So 1.0000 minus 1.0000. So what do we get here is 0.0000 minus 0.7727. So the overall answer here comes out to be minus 0.7727. So actually the answer for that log term is minus 0.7727. So we'll be simply substituting that value, okay? So here you have 0.763 minus 0.0296 multiplied by minus 0.7727. So the answer here for that multiplication is 0.023. Alright, so 0.763 plus 0.023, the overall answer comes out to be 0.786 volts. So I hope students you have got a clear idea with respect to this particular numerical. Thank you all.